Okay, Ziana, so we're going to do just some practice examples. You can already see them up on the board. This is from section 10.1. I'm not sure how far you've gotten past 10.1, but in 10.1 we start dealing with graphing the quadratic equation a that looks like the form of ax squared plus c. Now notice the typical quadratic equation that we'll eventually be dealing with has a b in there. So usually, I'll put it over here, it normally looks like ax squared plus bx plus c. Okay, but we're going to be talking about what happens if something is in the form of ax squared plus c, where b equals 0. So because b equals 0, you don't have to put it. Let's take this first one as an example. We want to graph y equals 8x squared. In this case, and I always like to identify the values of a, b, and c. So a equals 8, b is 0, and in this case c is 0. So if we were going to do that, like I say, with these equations, they're easy enough where you can just start out with a table. And so you can simply write a quick table, and I'll erase this eventually, but x and a y, and you can plug in the values. So you can, I always kind of go, well, I start off with -3, -2, -1, 0, 1, 2, 3. So those are going to be my x values. What would my y values be? Well, if x is -3, all right, if x is -3 and this is our equation, well, you can do this on your own. In fact, you should maybe pause this and do this on your own, and you should come up with the same answer. But we would have 9 times, or 3 squared is 9 times 8, that's 72. If we have a 2 plugged in there, that's 42. Is that, yeah, no, that's not. 32, sorry. And if we have a 1 plugged into there, or a -1 plugged in, that's -1 squared, which is 1. That just turns out to be 8. And if we have a 0 for the x, that just turns out that the y is going to be 0. And this is pretty symmetric here, so if we have a 1 in there, it's the same thing. It's going to, you're going to see the symmetry here. If it's a 2, that's going to be 2 squared, which is 4, times 8, which is 32, and 3, 72. And so therefore, if we wanted to graph that, or if we needed to graph it, I've got a graph here, and rather than going by ones, because I kind of have an idea already, rather than going by ones, we're going by 5s. So it's a little more difficult, because you sort of need to sort of guesstimate where the x is. But in this case, if x is -3, maybe that's somewhere around here. If x is -3, y is 72. So y is going to be like way up here. And that's a point. And then if x is -2, maybe -3 really is there. Anyway, if this is -2, then y comes down to 32. So now it gets down to about here. And if x is -1, now we're down to here. We're down to 8. So it's pretty steep. Pretty steep. And if it's 0, then it's 0. And then if it's 1, it's up to 8. And if it's 2, it's here. And if it's 3, it's way up here. So you can imagine a pretty steep curve. Now, the one thing that we can know immediately when we look at this, if we have to graph it, we can know that because this is the A and the A is positive, as we mentioned before, we know it's going to look like a smiley face. How steep it's going to be, meaning how narrow is it going to be, depends on, if this number is greater than 1 or less than 1. So because it's greater than 1, it's going to be really steep. And we already saw that. So let's try with another one. Let's try this one. Here, y equals x squared minus 7. A is 1. The b value is 0. The c value is negative 7. Okay. So, easy enough. You come up with a table. X, y, negative 3, negative 2, negative 1, 0, 1, 2, 3. And what would, now don't get fooled here, what would the y value be? Well, if the x is negative 3, then negative 3 squared is 9. Right? But it's not just 9, there's a minus 7, because y is the negative 3 squared, which is 9 minus 7, so that would be 2. Okay? What if x is 2, or negative 2 rather? Well, negative 2 squared is 4, minus 7 is negative 3. I can't scroll back enough so you can see everything, so you have to just know that it's x squared minus 7. Okay? So when x is negative 1, it's going to be negative 6. When x is 0, negative 7. When x is 1, minus 6. When x is 2, minus 3. When x is 3, this is a 2. Okay, now the one thing that I can surmise for the graph is that this, because the A is positive, I know it's going to look like this. And because it's a 1, it's it's going to look like our parent curve. That was the y equals x squared, the parent parabola. But because of this c here, that negative 7, that tells me that the vertex is going to it's not going to look like this, that in fact you're going to go all the way down to negative 7, and it's going to kind of go down like that. But let's graph it and see how that works. Okay, so when x is negative 3, negative 1, 2, 3, y is 2. Let's put that there. When x is negative 2, y is negative 3. We dropped all the way down here. When x is negative 1, y is negative 6. When x is 0, y is negative 7. And then we just go back up. Negative 6, negative 3, and 2. And so in this case, I see it goes all the way down, and here is our negative 7. Okay, so easy enough. Now that kind of curve, that's the kind of curve you like. All right, so last one. Did get this under 10 minutes, I hope. Y equals x squared, or negative 3x squared minus 2. Have our little handy dandy. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Now, just if we had to guess, like you don't have a lot of time to know what the curve's going to look like, the one thing you can say is, okay, it's a negative a. The a value is negative. Right here, a value is negative, so it's going to be like this. And because that's a negative 3, if this is a normal parent one, then it's probably going to be steeper. Oh, it's definitely going to be steeper. So it might look more like that. And it's likely that the vertex or the high point is going to be negative 2. But let's see here. I know we're over 10 minutes. All right. Remember, I'll plug in the values and keep the equation up there. If x is negative 3, that's 9. Negative 3 squared is 9 times negative 3. That's negative 27 minus 2, which would be negative 29, which I just wrote down. If the x is negative 2, it's going to be 4. That's negative 12 minus 2. That'll be negative 14. If x is negative 1, that's x squared is 1 times negative 3. That's negative 3 minus 2. That'll be negative 5. If x is 0, that should be negative 2. If x is 1, that's same thing. 1 squared. That's a negative 3 minus 2, that's a negative 5. I hope you're following what I'm saying as I'm saying it out loud. The next one would be negative 14. And if x is 3, that's 3 squared, that's 9 times negative 3, that's negative 27 minus 2 is negative 29. Okay, and here's the table neatly filled out. And I told you that the high point would probably be a negative 2, and you can actually even see a negative 2 in there. All right. You'll learn more about the vertex in 10.2. So if you've already covered that by now, you should be. There's a formula to find out the vertex. So x is negative 3, and y is going to be negative 29. So if we go negative 1, 2, 3. What's negative 29? And it's way down here. When x is negative 2, y is negative 14. When x is negative 1, y is negative 5. You see how it's climbing up. Negative 5. Oops. Negative 1. It's negative 5 there. Now when x is 0, y is negative 2. That would be up here. And then when x is 1, y is back down to negative 5. And when x is 2, negative 14. When x is 3, negative 29. So the curve goes like that. Just like what I said. I said it'd be sort of thin and it would be upside down. Okay. 13 and a half minutes.